Greetings, Dr. Mark Winton here from the University of Central Florida Department of Criminal Justice, and what I'd like to do in this brief video is just discuss a few small criticisms of risk assessment, specifically when we get into the newer neurological assessment strategies. First, I have some questions though, and the first one is what exactly is neural activity? You know, a lot of times we'll hear, well, electrical impulses fire in your brain, and but what I often wonder is, let me put it this way: if I open the freezer and pull out a quart of Ben & Jerry's Thin Mint Double Fudge Chocolate ice cream and start eating that, and my wife comes in there and says, Mark, you know, the doctor said that you should go on a low-fat, low-cholesterol, healthy vegetable diet or something like that. Shouldn't I just be able to say, I'm very sorry, but it's neural. My neurons made me do it. My neurons made me go to the freezer, take out that quart of Ben & Jerry's, and just start eating it. And not only did I not listen to my doctor, but I ate the whole quart. Or, I'm sorry, pint. I think it's a pint. Okay, I'm getting my measurements mixed up. That's neural. So how do we understand and evaluate neurological aspects of risk as related to violence? And so we are beginning to see a large amount of data collected on different structures and functions of the brain and parts of the brain, and those parts, how those parts are related to aggression and violent behavior. And I would argue that those are very important studies, and we should carefully assess them and use them, but also we have to think about the short-term and long-term implications as we proceed to get more technologically sophisticated at understanding how the brain operates. Because the one thing that always comes back as a question is, what about free will? What about free will? Then my wife might say, but Mark, you're from the school of thought that you have free will, you have agency, you're able to choose whether to go for that Ben & Jerry's ice cream or not. Even though your neurons are firing up, they're saying, Ben & Jerry's, eat that ice cream, you can override that, right? Why did you go to the Ben & Jerry's, but you didn't go to the broccoli and cauliflower soup? And I might say, well, because Ben & Jerry's tastes better. Well, why does Ben & Jerry's taste better? And then there's a whole explanation about how certain foods have certain effects on the brain. And, you know, the sad fact is my brain is predisposed with an affinity toward Ben & Jerry's ice cream. It just tastes good. It tastes a lot better than broccoli cauliflower soup. In fact, broccoli cauliflower soup tastes terrible. But it's good for you. It's good for you. And you can't combine those either. I mean, and, you know, sometimes you can kind of drown out the flavor, which is a whole nother area of the brain. So I use that example to kind of introduce you to the idea here about, you know, how we understand the brain and its functions. And then we begin to move into the area of brain scanning. And Professor Shermer talks about some flaws in brain scanning in his article in Scientific American Mind, published in 2008, Why You Should Be Skeptical of Brain Scans. And of course, these are very relevant still, even with the scans becoming more sophisticated. That first, he points out that when we conduct the brain scanning, it's really an unnatural environment. That when people are carrying out violent activities, they may be in their homes, they may be out in public, they may be in bars, but usually they're not carrying out violent activities in a fMRI machine. They're not during the scan. So it's a natural environment. So they're not getting an active measure of what the brain looks like when violence is actually being carried out. Although there are some ways of moving toward that, such as asking the person to visualize or fantasize about engaging in violent activity. Second, he believes it's an indirect measurement of brain activity. So we have some brain activity, but how do we know, specifically connect that brain activity to specific violent behaviors? That's a question we really need to answer. Third, he believes that the colors exaggerate the effects in the brain. So I put a couple pictures of brain scans on my slides here for you that you have if you're in the class. If not, you can just go to any site, really, look at brain scans, and you'll get all these images and their interpretations. Fourth, he points out that the images are basically statistics that have been compiled from a whole bunch of people to try to say, well, that we're more likely to see violent activity in people that have this particular brain scan than that. But there's not this consistent 100% accurate prediction, especially when it comes to what kind of violence and in what kind of situation. And then finally, he points out that the brain areas may activate for various reasons. So there may be multiple reasons why brains activate. So there might be a lot of skepticism toward using these in the courtroom. But on the other hand, there may be some beneficial research findings that we can use to prevent or treat those that engage in violent behavior, which is a whole nother presentation in itself. Now, Goodenough and Tucker, in their article Law and Cognitive Neuroscience in the Annual Review of Law and Social Science 2010, point out that we need to merge this whole area of brain scanning with bioethics. And they have some cautions and concerns as well. One is neurodazzle. That if you're presenting those brain scans, they look fancy. Most people don't understand how to interpret those. And so, I could easily pick up a brain scan and say, well, see, it's red over here. This means, that's the Ben and Jerry's area. Over here, it's green. It's a tiny little spot. That's the cauliflower broccoli soup area, and so on and so forth. And why would anyone doubt someone doing that presentation, because they don't have the knowledge unless they have studied that area. Again, there may be multiple factors related to brain structure, function, neurotransmission, and behavior. And finally, they point out that there's a risk of stigmatization. If someone is identified as having some kind of brain malfunction that's related to violence or deviance or something of that sort, then that may be a negative label that actually encourages that person possibly to engage in that behavior, or at least if they engage in that behavior, they have an explanation, and so on. And then they also point out that there are some further areas of interest that we can look at in the more recent advances, such as using brain scanning for lie detection. And it's actually been used in a court case, at least one court case, where they used a brain scan to try to determine if someone was lying or not. Also pain measurement. So people, they try to measure pain in a way where they can treat with pain medications to differentiate those that are suffering from pain from those who like the effects of the pain meds. And also mental capacity and mental illness diagnosis, is another area. And that's been going on for quite some time. Even 25 years ago, I can remember talking to psychiatrists about these emerging methods. Also memory reliability, and finally responsibility versus free will, which would have dramatic effects in the courtroom. And we also can look at how this all relates to medicalization and criminalization of behavior, how non-medical problems or non-criminal problems become medical problems or criminal problems or medical criminal problems. We also have demedicalization and remedicalization, and there's a whole history of that as well. I did want to mention real briefly that all of this seems to be related to mental health revolutions. And if we look at some of the past revolutions, we might see, if we start at psychoanalysis, we see that was very popular for a short period of time. Then the psychoactive drugs, the medications, really begin to emerge in the 1950s and 60s, and then the community mental health centers, partial hospitalization programs, new improved psychoactive drugs, managed care, more psychoactive drugs, and then brain scanning and mapping. So that kind of is the risk assessment risks in a nutshell. Thank you.